Okay, so now we're going to be talking about slopes of parallel and perpendicular lines. Well, we know what a parallel line is, right? We have these two right here. These two are parallel lines. The red and the blue. And we know that they're never going to touch. But why aren't they ever going to touch? It has to do with their slope. The slope of the red line is positive 1, up 1, we rise 1, and we run 2, 1 over 2. The slope of the blue line is right here, we rise 1 and we run 2. So their slopes are the same. So that's why they will never touch, because their slopes are the same. Okay? Now let's look at perpendicular lines. Well, perpendicular lines, you can see they're crossing. And the word perpendicular itself, the word perpendicular means 90 degrees, right? So that means that they're going to create a 90-degree angle. Now, so what does that mean according to their slopes? Well, their slopes are not the same, obviously, because they're crossing. But what they do have in common is when you find the product over here, the product, which when you multiply their slopes, it's -1. What does that mean? Well, you're basically taking the slope of this line and you're changing it. You're changing it to where whatever this times the new slope has to equal -1. So what you're doing is, number 1, you need to write this down, you flip it. And number 2, change the sign. Right? So if I take 1/2 and I flip it, now it becomes 2 over 1. This is a positive number, so then I change the sign to negative number, and I get -2. So that's what you have to do right here. 1/2 times the -2 is equal to -1. These are the steps that you need to write down for perpendicular. Now let's practice. A line passes through this point and is parallel to the graph of this equation. So they're parallel. They're going to run like this with each other. That means the distance here is the same in between. And then that means that the slope of this line is the same as the slope of this line. So if the slope is 2/3, we're going to keep the slope. We're going to keep the 2/3, okay? Now, so now we know M is 2/3. So we're going to use our famous slope intercept form. Okay, I have the slope. So now I just need to find out where that second line is going to cross the y-axis. You guys know how to do this now. I'm going to take that point, X and Y, and I'm going to plug it in here, here, and I'm going to use the slope and plug it in for M. Alright, so let's do that. So my Y is 5. 5. That's my Y. Is equal to my M is 2/3 right there. So I'm going to put in 2/3 right there. And then X is 12. I'm going to put it right there. Plus B. Alright? Here's my equation. Here's my Y, my slope, and my X. Now I solve it for B. So 5 is equal to 2/3 of 12. So 2 times 12 is 24 over 3, right? Plus B, which 24 divided by 3 is the same thing as 8 plus B, right? So then here, what am I going to do? I'm solving, so I'm going to subtract 8, subtract 8. 5 minus 8 is -3. This cancels, equals B. So now my B is equal to -3. And now I can write my equation. My equation is Y equals, since it's parallel, I keep the same slope, 2/3 X, and then now I take my y-intercept, -3. So if you graph these, and I'm going to graph them real quick, I'm not going to graph the other ones. If you graph these, this one here starts at -1, so I'm going to go to -1, and it has a slope of +2 over +3. So I'm going to go up 1, 2, and over 3. So there is my original line. Now I'm going to graph this line. My y-intercept is at -1, 2, 3. On my slope, up 1, 2 over 3. And sorry for my crooked lines. There's my two parallel lines. They'll never touch. Okay, now it's your turn. A line passes through -3, -1, and is parallel to the graph of y equals 2x plus 3. So now you're going to do the work, and you're going to solve the equation. Choose the right letter. Okay, so which one did you pick? So it's parallel, so it means I'm going to keep the same slope. So my same slope is going to be 2. I have this point, x, y. I'm going to plug them into y equals mx plus b. So my new y is -1 is equal to my slope, 2. X is now -3 plus b. Okay? So now I solve. -1 is equal to a positive times a negative is negative. 2 times 3 is 6 plus b. Okay? So now I add the 6, add the 6. 6 minus 1, 5. These cancel and I bring down the b. So my b is equal to 5. My new equation is y is equal to 2x, parallel, I keep the same slope, plus 5. Now let's do some perpendicular, okay? Perpendicular, let's locate our slope. So our slope is 1/3, but this is perpendicular, so we don't keep it. We do not keep it. We have to do those steps. Step 1, I flip. Okay, so if I flip 1 over 3, it becomes 3 over 1. Step 2, change the sign. Right? So once I change the sign, now it becomes -3 over 1. Okay? Which I can just use -3. So this is my new slope. The rest we're going to do the same. The rest, I'm going to take y equals mx plus b, and I'm going to plug in everything that I know. I know y is 4. I know my new slope. Remember your new slope right here. Let's get rid of that. My new slope is -3. My x is 2 plus b. And then we solve. So now I have b is equal to 10. And I always like to square them and put them close so I know how to write my new equation. So my new equation is y equals, I have my new slope here, -3x, and I have my y-intercept at 10. Okay, so when you graph the first one, we're crossing at -1. Our slope is positive up 1 over 1, 2, 3. There's my line. And then now when I graph this one, I'm starting at positive 10, maybe 10 up here. I'm going to go down 3 because it's -3 over 1. I'm going to go down 3, 1, 2, 3, and I'm going to go over 1. And I should cross. So there we go, perpendicular. All right, your turn. Okay, perpendicular slope, right? So then I do step 1, I flip it, and then step 2, change the sign. So here is my new slope. Scratch that out. Y equals mx plus b. My y is 8. My new slope is negative 1/2. X is 1 plus b. Then I solve. 8 is equal to a negative times a positive is a negative. So that's a negative because half of 1 is half. Right? Then, erase that. So now I'm going to add the 1/2, and I'm going to add the 1/2. So I get 8.5, but you notice up here, what's going on with the b's? I have fractions, I have this, and I have a 6. Okay? Is equal to b. So my b is, I got 8.5, but make sure you keep it in a fraction. Well, it's not 6. Right? So you have to tell me if it's 15 over 2 or 17 over 2, right? So my b is 8.5. So now I have y is equal to negative 1/2 x plus, what is 8.5? Is it 15 over 2 or is it 17 over 2? All right, it's 17 over 2, so your answer is B. All right. Are the graphs of these two equations parallel, perpendicular, or neither? How do we find that out? Well, this one is already in the form we need it. Y equals 4/5 x minus 8. We need to change this one. What's the only thing we need to do here? We need to get that y by itself, right? So we just need to divide by 4. Okay, do you see what I did? Y equals mx plus b because it tells me this is slope and it tells me this is y-intercept. And I need to look at the slope to determine if they're parallel or perpendicular. So when I divide by 4, I get y is equal, 4's canceled, negative 5 over 4 plus, and 12 divided by 4 is 3. So, are they parallel? No. Oops, there's the x. No, because parallel, this is 4/5, this is negative 5/4. So it's not parallel. Is it perpendicular? Well, let's take 4/5. Let's do step 1. Let's flip it. 5 over 4. And change the sign. Positive to negative. There you go. They're perpendicular. Your turn. Are they parallel or are they perpendicular? This one's a little harder because this is in standard form and you have to solve for y. Subtract the 4x, bring down the negative 3y, divide by negative 3, these cancel, we get y is equal to, a negative divided by negative is a positive 4 over 3x minus 3. So here, our slope, our m, is 3/4. Here, our m is 4/3. So it's not parallel, it's not the same. Is it perpendicular? Let's check. Let's do step 1. We flip it and change the sign. This is positive, this is negative. Uh-oh. Nope, it's not perpendicular, so it's neither.